Okay, hello everybody. This is Hechong Chen, and at this talk, I'm going to introduce my work on the, or I think it is a project on the deep learning based segmentation of the quasi-particles from experimental image. And I will divide my talk into three parts. And in the first part, I'm going to introduce you what the quasi-particle here, that is Skyrmians is. What is Skyrmians? The quasi-particles in physics. And the second part, I will introduce you the method that I use to perform the segmentation, that is the UNet. And the last part, I will show you some of my code and show you how the model trained and implement and how to evaluate the output of the training model. And at first, Skyrmians represent the class of topological excitation that occurs in magnetic systems. In the condensed matter physics, I think the guys from the physics or electronic engineering with some optics background will be more familiar with this kind of things. Let me show you some pictures of this kind of quasi-particles. At the figure A, we can see that with the spin textures, we know that electrons are the elementary particles in the physics, and it has different orientation in the spatial if the material has kind of symmetry. If we take a snapshot from the SEM microscopic, we can see their distribution as like shown here, figure D and figure E. And they are considered as the next generation devices for the storage and some kind for the storage. We can see that acceleration information storage and then even the neuromorphic computing. If you have some interest, you can look into the reference shown in the project reports. Due to time limit, I will now focus more on the quasi-particles. And at the second, we see that the quasi-particles, they have some spatial distributions, and we have to detect and segment them. So this, we have to use the convolution neural network method to do this segmentation of the images. So I choose to use the UNet CN model as the model to solve the problem in the physics. And the UNet is shown in figure 2 with the features with I've shown here 4 important features. That's 4 sampling blocks, and each combined to ReLU activation, and followed by max pooling and an expanding path with unsampling blocks using transverse convolution. And the third is skip connection between the upsampling and downsampling with the skip connections. And the last is a convolution layer with sigmoid activation function. Okay. I will going to show you the net, how the net trained. Let us run the code. And here to adapt the code into the CPU-based training, I squeeze the size of the image from 512 times 512 into the 256 and 336, and I reduce the number of the images that train on the model to like 312. Okay, because I only have to use the Apple Mac Pro to do the training. And let's see that. Okay. See from the report that we only load 312 images for the training. And at the process, we see that the accuracy keep going with loss, keep decreasing. And we only choose one epoch as the because due to the limitation of the computation source. Okay, this is the training process. And to evaluate the output of the model, we adapt Matthew correlation coefficient as a criteria for the our model. At the last part of our project, we show the how the dataset come and what the application software we use to do the training and evaluation. At last, let us see the evaluation process that which I have run in advance, that the piecewise Matthew correlation coefficient on the test set is 0.73 and on the complete set is 0.805. And I give you an example that this is the image that we have to do the segmentation, and the ground truth that is labeled by the human and from the data set on the internet. I also attach the source of the data set, and the predicted label is shown on the right column. You can see that they agree well with the ground truth and the curve image. Okay, this is my project report. Thank you, everybody.